Today, I'll speed up Earth's rotation on its axis, meaning I'll start shortening the length of a day. I'll gradually accelerate the planet's rotation, watching how Earth changes right up until the moment of its total destruction. And after that, I'll perform the same experiments with other celestial objects as well, all using the Universe Sandbox simulator as an example. Let's go! We all know that a day on Earth lasts 24 hours, but what would happen if we shortened it to 18 hours? Let's see how that affects our planet. I'll speed up time to 1 day per second and hide the atmosphere and clouds. But here's a fact. The faster Earth rotates, the more water shifts toward the equator, while at the poles, conversely, it starts to recede. So let's check that out. Near Greenland, it looks like some land has appeared here, but it's currently unclear if it's actually land or not. However, it is as if Greenland has joined with Iceland right here. And if we look at this part of the planet, we can see that two continents are simply joining together in this spot. Land is actually starting to appear here, and there's more and more of it. At the equator, on the other hand, some areas should be flooding, but so far, nothing particularly stands out. Maybe they've flooded somewhere, but visually from space I can't distinguish anything yet. But guys, the more I speed up the planet, the more water will collect specifically at the equator. A bit later, you'll be able to see it with your own eyes. And now, I'll set Earth's day to 12 hours. Oh, Earth seemed to shift a little bit there. And let's see what's happening to Earth here. And as we can see, the water is receding significantly off the coast of North America in this specific location. And the visible landmass has also noticeably increased near Greenland. Here, as we can see, there's more land now too. And we see a lot of land right here. Well, the equator should be flooding. Let's check. Again, 1 day is passing per second. And I'm noticing that water seems to be starting to penetrate the Amazon basin in South America. I'll speed up time even more. And yes, it's truly beginning to flood quite seriously right here before our very eyes. And the water is actually just surging quite deeply into the continent along the Amazon River. And we see that the coast of Africa has also started to flood here. So it turns out I've effectively doubled Earth's rotation speed, but I do not see it significantly affecting the planet's average temperature yet. But the habitability has dropped to 83%. The magnetosphere is still there, as we can see, so that's fine. But one thing is clear, the faster day means that winds on Earth will likely become much stronger. More time has passed while I showed you the stats, and we see South America is quite flooded now. And in Africa this is the situation, with water continuing to rise bit by bit. And these islands here are also starting to get submerged. And now, a day on Earth will be 6 hours long, and let's look at the consequences. We see Central Australia flooded immediately, while New Zealand gained a lot of new territory. And by the way, this territory is growing and growing, as you can see for yourselves. And as you can see, New Zealand has joined with Antarctica, even that kind of outcome. Oh, the northern part of Australia has already gone completely underwater. Let's see what's happening here. A lot of land has appeared in this spot, while here at the equator, almost all the islands are already underwater. And here's Central Africa. It's simply been washed away, roughly speaking. Wow, and the Sahara Desert is slowly being flooded. A large lake like this has even appeared right here. And you can see for yourselves how Central and South America look now. Almost everything here is flooded, only the highest mountain areas remain. But here, the northern part of the Atlantic Ocean has simply disappeared. And this is how Earth looks from space now. As you can see, it's become quite oval-shaped. But that's not all. Next, I'll make a day on Earth 3 hours long. And as you can see, that's made Earth even more oval. I'll speed up time, and I've hidden the atmosphere and clouds. It's clearly visible how water is moving from the poles toward the equator. It's slowly moving south like this. The same thing is happening in the southern part. As we can see, almost everything along the equator is flooded, with only minor high altitude spots left, while the polar latitudes are nearly dry. This is what our planet has become now. And by the way, because of this, I see the average temperature on Earth has risen slightly, by about 2 degrees Celsius. The likelihood of life has already dropped to 65%, but the magnetic field is doing fine. But for now, on an Earth like this, the simulator shows that life persists in some places. But what happens if a day on Earth becomes 2 hours long? It's been very seriously flattened now. Hiding the atmosphere and clouds, we see this situation. Water is only along the equator, and by now, everything at the equator is completely flooded. Well, and here is the situation. Life, as we see, still remains for now, although there are terrible winds here. It's probably impossible to live on a planet like this. Here, I'm showing you the northern hemisphere. This is how the whole thing looks. There's only a little bit of water here at the pole. Oh, the average temperature on Earth is already 23 degrees Celsius. The temperature has risen significantly, and the likelihood of life is 56%, getting lower and lower. And this is what Earth looks like now if its day is 2 hours long. And now Earth will have a 1.5 hour day. Oh boy, what's happening here, guys? Earth's rotation is so fast that matter is even starting to break away from it. And of course, these particles return, causing impacts on Earth like this, and because of that, life on Earth will finally vanish. By the way, I'll hide the atmosphere and clouds, and let's look at this. Well, a little life is left here, but as we see, life is starting to disappear here too as the shockwave moves, and so life on Earth finally disappears completely. And this is how it all looks from space. I'll remove all these particles and we see that Earth has lost a bit of mass and radius because of this. And the temperature on Earth is already enormous. Right at the impact site, it's over 2000 degrees with an average of 748. As you can see, there's no chance of life here at all anymore. It's less than 1%. But I'm continuing, and now a day on Earth will be exactly 1 hour. Oh, and this time even more fragments are flying out. Now Earth is going to seriously lose its mass. I'll speed up time even more. Oh my goodness, look at all the particles and glowing gases here. But Earth has flattened even more. As we can see, everything is so red hot here that we can't see anything at all. If you hide the atmosphere and clouds, the Earth has simply melted like this. And the average temperature here is about 3000 degrees. Well, everything is clear here. Earth lost almost 20% of its mass and about 6% of its radius. And now a day on Earth will be 30 minutes. Oh, look at that! I need to hide everything again because nothing is visible. But for now, Earth exists. At least it's not being completely torn apart. The mass of Earth has already decreased by more than half, and the radius by about 23%. But now I'll set a day on Earth to 15 minutes. Earth still exists. I'm surprised. What if I speed up time? Yes, it really exists. But apparently Earth was saved by fragments that quickly slowed down its rotation speed. But what if I try to set a day on Earth to 15 minutes again? Oh, now nothing could save the Earth. Earth has simply completely crumbled away, as you can clearly see. Even the core, nothing survived. Now let's check other space objects in this same experiment. Here, for example, is the gas giant Saturn. Its day is almost 11 hours long. But what if we make it 5 hours? Well, Saturn started wobbling like this. It flattened out. Now what if we set Saturn's day to 2 hours? Oh. Look how much matter and molten gases were ejected from it. But it exists, though it apparently lost its mass. And look at its rings. Its rings started flying away from it. That is most likely due to the loss of mass. The rings are scattering. I'll hide these gases. They're in the way. And the day on Saturn self-restores quite quickly. But have you wondered what happens if we set its day to just 1 hour? That was absolutely brutal. Saturn still exists, but it is incredibly flattened out. Well then, I'll set its day to exactly 50 minutes, and that's it. It just couldn't take it and completely collapsed. Now let's try the same with Mars. Its day is 24.5 hours, but I'll immediately set Mars's day to 2 hours. Oh, how it flattened out immediately. And a bit of matter, as we see, has already managed to escape from Mars. And this kind of dust is rotating around it. Well, here it will likely be a similar situation as with Earth. The day has stabilized a bit and increased, but now a day on Mars will be 1 hour. And now there are more fragments. There are so many of these fragments that they simply heated Mars up by returning back down. I'm clearing away every single piece of this debris, and Mars looks like such an intense glowing object. The day self-restored to almost 2 hours, but now I'll set the Martian day to exactly 10 minutes. Starting the simulation. And that's it. It couldn't take it and completely exploded into particles. Huge fragments are flying away from it. Now let's also check the sun. I'll set the informative mode in the simulator so the sun doesn't burn your eyes. The sun has a fairly long day, if you can call it that. 26 Earth days, and the sun will immediately have a 4-hour day. And the sun started wobbling like this. I'll speed up time. Well, overall, over time the situation stabilizes, and the sun now looks like such a flattened star. By the way, such stars do exist. Take Vega for example. Well, now the sun's day will become 1 hour. And here, as we see, many fragments are breaking away. Basically everything similar to the previous objects. Looking at the mass and radius, the sun has already lost half its mass, and its radius is way down too. If we zoom out, we see this interesting view. And now something's starting to happen near the sun. Look, a lot of particles suddenly started breaking away. Let's keep watching to see what eventually happens to the sun. No, this is totally insane. It's crazy. I've never seen anything like this in Universe Sandbox. The sun's rotation is so fast that matter is constantly flying off, but gravity pulls those particles right back in. And so this endless cycle continues. How long can this go on if I speed up time? After a while, everything actually stabilized, as it turns out. Well, now a day on the sun will be 15 minutes. And because of that, the sun was immediately torn to shreds. Now let's check the Crab Pulsar, a star that's already spinning at an enormous speed around its axis. I even slowed the simulation speed down to 1 millisecond per second right away, just so we could see something. And as we can see from the specifications, the rotation period of this pulsar is 39 milliseconds. That is incredibly fast. I'll start by setting a day on the pulsar to 10 milliseconds. It started spinning faster, but it didn't even flatten out, so it doesn't care about this rotation at all. But what if the rotation period becomes 1 millisecond? Oh, and that of course starts to stretch it out. I'll speed up time. And over time, everything stabilizes like this. Now Now I'll just make it half a millisecond. That looks epic, speeding up time. Well, basically, over time it all stabilizes into this look. And that's how it all looks now. Basically, the pulsar is still alive for now. And now, the pulsar's rotation period will be 1/100th of a millisecond per second. Oh, and that is the exact moment when the pulsar completely tore itself apart. You probably have another question. What if we try this same experiment with a black hole? Let's take, for example, the Sagittarius black hole. I even gave it an accretion disk like this. Well, it seems to have some rotation period, but here it's actually 0. If I set it to, say, 1 hour, and I also set the simulation time to 1 hour per second, nothing changes at all. Since that's the case, I'll set a 1 millisecond day for this black hole. No, as we can see, this parameter doesn't affect the black hole at all. I'll even set it to 1/100th of a millisecond for the black hole. Same thing, you see, nothing changes at all. So these are the results we got. As you can see, rotating at high speeds around its axis can be very dangerous for cosmic objects. If you enjoyed this video, please give it a like and leave a detailed comment below. It truly goes a long way to help promote the video to others. Thank you very much.